Hello, so I want to take a moment to show you how I'm going to run through this problem number 9 from our homework 2.9 just using Desmos. So this is another way to deal with these more complicated functions. I have a few things set up here. I added an image of the actual question here in the middle of the graph, and then on the left in the entry portion of the screen, I just put some labels in so you can see where I'm going to put some things. So let's start by adding our cost function in, and all I do is just hit enter and it gives me a new entry blank where I can put an entry. I'm going to name the function c of x just like it looks in the question, 128, and then square root. If you're typing on a computer, you can just type sqrt, but if you are using the keyboard or if you have it on your phone, you'd have to go to the little keyboard button here, and then you can hit the square root key, which is down here. Square root of x, make sure you go outside the radical sign to put that plus sign, and then do x squared divided by, divided by 64,000. Okay. Now, a few features of Desmos. When you type a function in, it automatically draws the graph, and this one's going to be labeled in green because of the way we have our axes set up right now, so you can see the question. This the green function is barely showing here right along the axis. This function grows very quickly, and so it's shooting off there, and in order to really see the function, we would really have to adjust our x and y axis a little. So for example, I happen to have played around with this a little bit, and I know I got to go up to about 6,000 before I start seeing stuff. Actually 600 worked. And then here, we'll go out to like 2,000, and now you can kind of see the shape of that graph. Okay, so the function is there, but I'm going to go back to where we had it here. But right now, because of the way we have the coordinate plane set so we can read the question, you can't really see much of it. All right, so the first thing that we're asked to do is find the cost at the production level of 1,200. All that means is we need to plug 1,200 into this function. We've already got it typed out, so if I hit enter and make a new line, I can just put 1,200 in, and I find out that my production level is, or my cost is $4,456.55. So that's what I'd put into this first blank, $4,456.55. The next thing they're asking me to do is find the average cost of production. So you have a couple of options. I know that I'm going to need the average cost function a little bit later, so I'm going to go ahead and type that one in here. Normally we would call this C bar of x, but I can't put a C bar in on Desmos, so I'll call it A for average cost, A of x. And remember, the average cost is just C of x divided by x. So I've set the function up. It will show up as red on my grid. You don't see it now because the values aren't in the domain that are on the screen here. But specifically, we're asked to find the average cost at a production level of 1,200. So it's just going to be that 4,000 number divided by 1,200. But let's go ahead and just type that into our function, and we get $3.71, and that'll be my second answer. The next thing we're asked to do is find the marginal cost at 1,200. So let's go ahead and graph our function. If you want the graph to show up, you just put C prime of x. And that green, that's green. Let's change that to a different color. Let's make that one purple. So our marginal cost will be purple when we see it over here. We're not ready to do that yet. We're still doing values. And we want the marginal cost at 1,200, so that's C prime of 1,200. So the marginal cost would be $1.89, and all that means is that the cost that we'll have to pay to make the 1,201st item is $1.89. And then finally, we get to the question where we have to actually use our optimization. It says, what's the production level that will minimize the average cost? So to minimize something, remember, we need to look at the derivative. So I want to graph the derivative of this average cost function. That means I want to draw a prime of x. Oops, I put c in there. Let's put an x in there. Okay, so that's a black curve. And notice that black curve has showed up on the graph. All of these graphs are actually here, but this is the first one that kind of showed up there. And it starts out in the negative fourth quadrant there, and then it keeps growing. We have to find out where this thing crosses the x-axis. So basically what we need to do is keep going further out on the x-axis until we see where it crosses a line. Remember, if you just tap this function, it'll put a dot where it crosses the x-axis. But right now we can't see that because we're in the fourth quadrant. So let's just slowly expand out the x-coordinate. I'm going to take it out to 1200 because we've already used that value, so we know that's an interesting production level for this particular problem. So if I take it out to 1200 and I tap the black curve, we don't see a dot yet, all right? We don't see that it's hitting that x-axis yet. So let's take it out to like 3000 and we'll see if we can get something to show up here. So I'm just kind of guessing and checking here. 3000, oops, that's 30. Let's go to 3000, and if I tap it again, does a dot show up? No, it doesn't. So we'll keep going. Let's go out to 5000. Tap it again. Still no dot. All right. Well, I've had it with this. Let's go out to like 50,000 and see if I tap this thing. You know, eventually we just have to get it out there. Yes, it finally showed up. So I had to go quite a ways out, but notice here's the dot. That is the place where our average cost function crosses the x-axis. It goes from negative to positive. So at a production level of 25,600, that's going to minimize our average cost. Right? Is that what we were asked to do? I got to go back to the picture and find out if I'm answering the right question here. So let's slide over. Let's get our image on the screen. It's really small right now because of the way we did this, but we'll make it bigger here. Oops. We're trying to find the production level that will minimize the average cost. So we want to go from negative to positive, which is what we did. All right. If you want to move this off the screen, you can do that. So at, what was that, 25,600? Yeah, right there. That's the value that will minimize the average cost. And then to find out what that minimal average cost is, we have to plug that 25,600 into the average cost function. So I'm going to come up here to my average cost area, and I'm going to put in 25,600 and see what my minimal average cost is. The lowest we will get to is $1.20 when we do that. So this problem is interesting and not easy. If you're doing it by hand, you'd have to calculate all these derivatives and things on your own and then plug a bunch of numbers in and solve equations before you found these. I think using Desmos for a problem like this with a function that's this complicated is much more practical as long as you know how to use it. So I'm just going to say again what we did. The first thing I did is I put my average or my cost function in exactly the way it was written. And then I computed the cost at the production level of 1200. So I did C of 1200. The next question asks about average cost. So the first thing I did is create my average cost function. And then I plugged 1200 in to get that average cost at the 1200 level. That means the average cost for each of those 1200 items to us is $3.71. They also ask for the marginal cost at 1200. In other words, what's the cost for the next item for 1,201? Even though the average was $3.71, the cost for the next one is only $1.89. And then finally, they wanted to know what production level would minimize the average cost. To do that, first I had to graph the derivative of the average cost and look for the critical number, right? Which was 25,600. I had to look to see where that graph crossed the x-axis. So I had to do some work to find it, right? It didn't show up right away. Eventually, I found it over here at 25,600, but I had to adjust my x-axis so I could see where it crossed. And it's not a great picture because this function has a weird behavior. But we found it. That's the equivalent of writing this equation out and setting it equal to 0 and solving it. So we do have to do a little work still to solve it. But once we found that production level, then you can plug that into the average cost to see what your average cost will be when you hit that minimum. The minimum that we'll get for averaging out these items is $1.20, and that's only after we produce 25,600. So I hope this helped a little. It's another way to solve these problems. You don't always have to do things by hand. We have these modern tools that help us do math a little more efficiently. And so I welcome you to use it as part of your toolbox for solving some of these problems. If you have any questions, you know where to find me. In the meantime, take care.